What's up, guys? Welcome back. And today we continue without with our DBML parser. And for today, what we discussed last time, what we planned is to implement actually the schemas on everything, and on tables, on nums, on columns when we reference them, for example, in refs, and so on. So we've got plenty of work to do today. Let's go. Let's start from basics. Let's start from table. So it says that we don't have to define schema somehow separately. We just need to specify it before the table name, and it would be the schema. So the idea is very like simple, not simple but similar with all of usages of the schema, because it's always optional. So we always somehow have to check if we have a schema specified or just the name. And the thing is, for the table, it would be we check the first token, and first of all we assume it's just the table name. Then if we got a dot after it, then we say that what we got here is schema. And next we expect another kind of name thing, entity name. So it is the name of it. And if we don't get one, we throw an error because we expect it after the dot. And that's it. It would be a bit trickier, just a little bit for example, refs. Like here, because we might have like schema, then table name, then column. So we have three such names here, and we would have to check like for those two first of all. Then if we got another dot here, and we assume that this is a schema, this is table name, and then after a dot we expect column name. So this is how we plan to do it. Now let's try to implement it. So let's go into our parser. But first of all, we have to actually add it into, for example, our table. So we go into table, and this is the column. This is check index table. Yes, so we have to add it here, and it is optional schema. Yes. Okay, and we have to print it. So here what we say is if table schema, then we do table schema value and a dot. And here we say out table name, yes, just table name. Okay, this is good. Let's now look into parser, where we have consume table. Yes, so we have this table name is consume entity name value, and we have, this is correct actually, because we just expect some name as here like this. We just now what we say is if pick is dot, then we say table schema is table name, we consume this dot, and we say table name is again consume entity name value. Just as simple as this. I hope this works. Let's try. So let's go into our test, and we have the table, and we say the schema follows. Here we don't have any of those, and let's just check. So again, I have to define the alias is, maybe we would do it in a separate tab. So we say alias one is make build and build the DBML parser. And let's look. Yeah, we got it here, and here we didn't get it. So this is cool. It was really easy, simple, but let's not get too much ahead. And let's now, I guess there's no reason to check with those like quoted names, because it's covered by tokenizer, and it, at least by experience here, we don't have any tests, but we test it manually, and it usually works well. And I would say it always worked well, at least in cases we tested and covered. So that's okay. Now we might need to implement the same thing for enums. But actually, maybe for enums we would do it later, because there is a problem with enums, and that's they then could be used as a stable column types, and we have to maybe somehow distinguish between just an arbitrary type specified and this particular type, the enum type specified, so we can check it. And let's actually see what happens if we add some schema here. So if we say, I don't know, ABC varchar, it actually passes it, and it's totally legit, and it doesn't even highlight this anyhow. But what if we say enum ABC varchar? It's possible, and we say entry, yeah. And what is the warning? Right. Okay. So this is legit, but it's not anyhow related, as I see. It doesn't recognize it as this one, although it recognizes it somehow here, because it's this type. What if I just specify some random thing here, like just ABC? Then it says it's totally correct. So it's still, at least for those records, it somehow checks what type it is, and if it knows the type, then it would say it's incorrect, even if we have something like default, and this doesn't complain. If we uncomment it, yeah, it also doesn't complain here. So we might leave it as it is. So we don't have to validate the types actually. But the thing is, what if I specify like parameters? You see, it doesn't validate it anyhow. It doesn't check that this is actually a num, and maybe it doesn't need any type parameters. So for now we would stick to it as well, just to like comply to DBML as it works at the moment the most. So then it's much easier. The thing is, we have to parse the types a bit differently, because for now what we do, we treat it as a separate token. That's the problem. So if can I specify like the third one? No. So still it identifies it as a schema because it doesn't allow like third one. So that's interesting. Maybe I would have to somehow specify in type that it has some schema. So but if it has schema, it still can have parameters. So yeah, this is how it is. Okay, then we might go into announce, but maybe yeah, to be consistent as we implemented for table. I mean, those would be for refs. Okay, let's implement for now for enums and then go to refs. So let's go back into enum, and enum might have as well. It's optional. View schema, and here it would be similar. So we say if it has a schema, then print this dot, and here we print the name, and that's it. Now if we go into parser again, here is the table, and what we need is actually just a copy of it. So copy it, go into enum. Here we have this consume entity name, and just paste it. Let's space it out a bit, and maybe we also move it. Now here we just replace. So let's use this place table with enum. Yep, good. This. Yep, this looks good. Okay, so now it should work for enums as well. Because the thing is, we have to now modify the column because its type might have schema. The question is actually how to really store it and then represent. Maybe we would really store it as it is, just to store a schema separately. So it's an optional thing. Okay, this we written. Let's now go into, or for now, let's just. I don't think we need to test it. Should work okay. But maybe, yeah. Let's go into. The test, and we have here enum. Maybe we just add some ABC. Test it, and yeah, we got some error. Oh yeah, we have to print enum. We have to print schema value. working now, and it's okay. Cool. So now we move again into the table and into the column. So we have this data type, and we have data type schema. Maybe we would move this data type into a separate class, maybe. So it would have schema, name, and args. Yeah, I guess it's a good idea. Let's even move it right now. So let's copy it. And here we have this. We just remove all of this. The name, it would be schema, and it would be the args. And we have to print it as well. Let's go somewhere here. Yeah, here we have it. I'll copy all of this. And here we have, instead of column, we have this data type. And type is not reserved, okay? I repeat, type. And here we don't need all of this. Just print, or maybe to be consistent, let's then name it data type. So we print its name, but first of all, we check if data type schema, then we print it and a dot. Here we print the name, and yeah, I have to use value. And now if, and here we remove this and args, and the same here. Yep. And at the end, we returned out and close that curly. So now here what we can do is just remove all of this. Move this, and instead let's say so printing data type, and that's it. Let's see if it works at all. No, because we don't parse it correctly. And yeah, struct definition. Here we have to add this one. And I forgot to remove those. Yeah, so let's go into Parser and modify it. parser, and we need consume column. Now data type name is this one, and again we would need to, so let's add no. We would have to add the to do schema, and here we say not much is changed, we just like nest it. So now we have to, what is 257? Okay, we go into consume table, just get this 257 and paste it, remove it. If there is a dot, then let's do one. So we change table to column data type. Yes. Yes, let's try it. Yeah, I probably forgot to add it. So we go into the table, and we have name and data type. Yes. See, and I called for the name for some reason. Let's remove it. Yes, at least it worked, but now let's check the types. Yes, yes. At least I see params and stuff, so it seems to work okay. All right. And most of them don't get schema, but what if we now add one? We go, I don't know, here and say this. Yeah. So it works. Cool. Cool. So then what's next? Next is to go to refs. And in refs, we basically have to do the same thing. But instead of just one, we get like two tokens, two names. And check if we get the third one, and we kind of shift it. Then we say table is actually a schema, column is actually a table name, and the third one is the column name. So it might be trickier with those, because you see we might have parens here. So we would have, well, first we just implemented for, oh, what is this? I just accidentally noticed, why do we print ref twice? Oh my god, this is not good. So in the column, when you print it, we print setting ref. Maybe we have to really remove it from here. So this is inline ref. We just remove all of this. Now it's only one ref. Yeah, because we implemented this setting printer. We have to do it. Okay. Now then, what we have to do is to those refs maybe add a schema. Again, do we have any optional string? Yes. Okay, let's. Oh. Yeah, this one, and it needs to be schema. And here it no longer can be just a one-liner. So here we have to split it, say if ref schema, then print it and print a dot. And here print the table and the column. Okay, and let's go into Parser. And the consume column. This is type. And here somewhere we have a ref. Incremental ref. Here we are. And yeah, this is the kind. Now this is the table. We consume the dot, we consume the column, and here we have to add this extra check. If pick is, if it's a dot, then we say ref schema is ref table actually, and ref tables is actually a ref column, and we consume, and we say ref column is again consume name value, like this. And it should work. Let's go here again, change somewhere where we have refs. We have a ref here. Let's say again ABC, run it. And yeah, we got it. We got it. But now let's then test it. Do we have any ref here again? Not much, not much. So let's add it somewhere here, just test, and then a ref, this one, and some table column, just to test it. Yeah, we got this right. Okay, cool. Now what we might want to do is to then implement it for those, like, not inline but regular refs, those that we define outside of tables, and we have them somewhere here, consume ref, and we have to do it twice. So here are the left hand side, and it goes the columns, which is just the table name. And if we got parens at this point, just right after the first name, the first part, it means we don't have a schema, because like we cannot have after parens anything else. I mean, when they close, because it strictly means those columns here. So this we just skip, But instead, here what we have those left columns, pushback consume name value. And now what we do is we say if pick is dot yeah. If pick is dot, then we consume it, and we say ref schema is ref, how is it, left table, or if we have ref left schema is ref left table. Maybe, you know, maybe we would somehow have to abstract it a bit and just to be able to say ref dot left dot table. So left table, and ref left table is ref left columns front, and ref left columns front is consume name value again. Yep. And we would have to do the same, so just copy, go here, here, and just replace left with right. Yeah. Now we go into ref itself. We have to add it. Here we have name form, and we here have let's copy it. Go here and say left schema, and again here, but it would be right schema. And here we say what? Left hand side, table name, so we say if ref left schema, and we print it, and print a dot, and then table, let's copy it, go here, and place it, and it should be good. Let's check. Yes, let's now then try to add some schemas here. So we have interesting. Let's see what we have. So this is schema table, and then we get the columns. That's interesting. Yeah, maybe the way we did it was incorrect a bit. Just maybe. This is tricky actually, as I said, because yeah, the brands we can have them like at second place and then nothing at third at all because we cannot have anything there, or we can have it like after the schema name and table name. Oh, this is a bit tricky, a problem that than I thought from the beginning. So if we go into the parser and somewhere even somewhere here, so column, we need to consume ref. So we got the table name, we got the dot, and we check if we instantly got those paren open. Then we just parse them. Otherwise, so basically somehow we need to check if it's not a paren open, if it's a dot. Because I don't want to duplicate this paren open code here somehow, you know, here basically. So because yeah, here actually we might have after the dot parens, and this is where it failed. So let's think what we might do. So if after the dot it's again the name, it means it might be the first column how do we check if it's a name? Because consume name just affects it. It consumes it. The only thing is we can check if we got something, but it's not the paren open. So what we say if not peak is it's not paren open, and we basically do this one. We just consume name and push into it, because for now we just expect we don't have a schema. Now what we say is if peak is dot, then we expect something else. Then we expect just paren open or just single column. So if it's a dot, and we have a lot of going on here, because it means what? Ref schema is ref table, and ref table is ref columns front. And we would need to empty ref. Or it's clear. Yes, I remember it's clear, so we have to clear it, because we would push columns into it. Here we don't need this. If it's a paren open, wait for a second. If it's not paren open, because if it is, we have to just move into it. If it's not paren open, goes next, and goes into it, and just moves next. Because if it is, we have to skip this as well. Because after this dot, there might be, maybe we have to move it kind of like this and move it. Yeah. So we move it 5, maybe like this. So if it's not for an open, and here we can have not else, because this is optional. Let's think how it goes. I really confused myself a bit. So what we have here? We've got name, got the dot. Now we check if after this dot we get just for an open. If not, then we just consume the next name because we expect it to be the column name, single column name. And we check again if we see a dot again. We get all of this and we have to consume it. Consume it. So if we see a dot, consume it, and we expect another what? Nothing, because next we might have for an open or the single column. So this is for the left hand side. Let's just try for it and see if it works. Yeah, this is okay. No. Expected a word or a quoted string. I'm curious where this fails. Clearly fails on some consume name, but I'm not sure at which one because we have many books. We have here. I'm just staring at the screen, completely confused a bit. I don't know why I cannot gather my thoughts together. So let's then try to somehow debug it. I don't know. Have this consume name. We got this dot. We got the table name, which is basically it failed. Wait a minute, it failed on the first ref, right? Because here we got some. All right, so let's check what we have. We have here. So it failed even here. So expected something here, but got this left one. So it moved here. Okay, so we have table 1, column 1, which is totally legit. Let's see what we would do for it here. Let's even write us of a column. So we have this column, or is table 1, column 1, or just table column. Have this column and this left and something else. So now we got the consume name. We got this with it. This one. And now we consume this dot. And now we see, do we have a parental? No. So we just consume this name, push it into the list. Now, I see. So we got somehow into it. Yeah, I see now the problem. So we just always expect the schema to be specified with this one. Because we consumed this dot, but we didn't see the dot, right? We need to do this. So we've got this dot. We've got here We didn't see a dot, so we just skip it. Now we didn't see a paren open, so we just expect something here. Maybe here what we have to do is add this check for a dot, because, or no, because I'm not sure if it's correct that we consume the dot here. We just have to reset it. Let's try to do think is and just move everything into it. Yep, yep, it for some reason just worked. I have to fix this one a bit. Printing the ref name. We quickly do it so I don't forget it. Ref and yeah, where is the ref name? Name and right here. Go into Parser. I consume ref, and this is it. This is it. So let's see what cases we have. Just table, column, again table and column, and schema table column. Let's then modify it a bit. So we have here schema. Here we have those things, and yeah. Yeah, let's now see. Table, do we have it like this? No. Yeah, we have it like this. Or do we? Let's really about table, yeah. Now schema, and we just want column, schema, column, right? And now schema and columns, and table and columns. Schema, columns, table, column. Yeah, right. Perfect. This works. Cool. Right. And now we have to just do the same for the right side. Let's delete it. Probably I just copy it and substitute it here. Yeah, probably to do it again, not so proficient. Good moves. I sometimes just forget what to do. So left and right. Yeah. Yeah, okay. Okay. Oh, wait a minute, really? Oh, it's okay that I didn't add schemas here, because let's then try it again. Maybe, yeah, it doesn't work. It doesn't work. I forgot that I didn't add it for the second one. And we got some crazy problem to solve. Segmentation fault. What is going on? So it failed somewhere here on parsing this one. Table2 dot params. So what happens? Let's check again. Oh, what options do we have? So it's table and column. We consume table name, consume a dot. Check. Is it parent open? No. Skip it. It is a parent open. Skip it. If it's a dot. Yeah. Yeah, so this is still incorrect. Let's really see what options we have. So we might have schema, table, column. We might have, let's even add it here. Table, column. Here we have table, columns, column 1, C1, C2, and schema, table, C1, C2. We can distinguish between them. So we always just consume this dot and name and dot. And next, so we can just remove it. Now what we might have next? We might have run, or we might have another entity here, another name. So those are two options. It's either run or yeah. If it's run, we kind of have to short circuit into here. So basically those two are close, and those two are close because it is like this. Now after we consumed it, let's remove it for now and to write it. So we consume this dot, and this is where we are left. So we can consume again a paren, or so if not peak is paren open, then we surely consume name, and it is ref left columns push back consume name value. So we got rid of those. Now we might just stop in it with it here. So I would even move it like this. So we've covered those three. Now we have to check if we got a dot, then we might have something else. So after it, and so here we say maybe if peak is dot, we consume it, and if not peak is not run open, then we say, and here it's a dot, we have to say left schema left table left tables left columns front, and constant or clear, right? Super open. If it's not ever open, so we just ref columns push back same name value. So what we've covered here, we've covered this, we've covered this, and those dots, and what we might be left with is, and we actually covered after the dot this column. So we might have just got, we might not get this thing, and we just need to do this, and yeah, this should be it. Let's check, and let's really define all those test cases. The left hand side at the moment have table column. Let's just copy it and have schema table column, and here we would have then just what table column and schema table column, right? Let's run, and we've got segmentation fault on the right hand side. Let's fix it again. We have table column table column, schema table column, table column, schema table column. Right, looks good. Looks good. And then again, just copy all of this, paste it here, and delete the wrong ones, and replace. Now again, let's copy and no, we cannot do it. So let's just let's do copy this. What's wrong? Yes. And paste it here, and let this paste it somewhere here, and just here, and schema, and yeah, here we have a schema. Let's run it. Now let's compare it. So we have schema table columns, table column. Yes, table column, schema table columns. Yes, now schema table column, table column, schema table column, table column. Yeah, right. This is correct then. This is correct. And I'll just move it into a separate function, but for this, what I need to do is to really abstract a bit this kind of hand side of the ref. So yeah, let's go into ref somewhere here and say struct ref hand side, or maybe just ref side, ref target would be ref side. Let's do ref hand side. Here we would have what? We need this. And just place left with nothing. Yep. We would have nothing of this, just have ref hand side left and ref hand side right. And we need a print operator for this hand side. So yeah. And what we have here is this side. Get all of this, put here, turn out, and here we would replace just ref left with the hand side, or hand side dot set schema, maybe even just let it be hand side. Yeah, left hand side. So out ref left. Ref right. And we have to change the way we parse it. So basically what we have to do is replace ref left with ref left dot. Yep. And somewhere here the same. I always forgot. Always misclick. So ref right with the ref right dot. Yep. Yeah, we got this. We got this. And actually we might reuse it for inline refs, but I'm not sure if we should. Because it would kind of from the schema level imply that in inline refs we might have multiple columns referenced, which is incorrect. That's why I don't want to do this. So we only abstract it for here. And yeah, what we need to abstract else is how we parse it really. So let's go and say with void, but actually ref hand side maybe. I'm curious, like, should we fill it? Should we what should we do it? Let's just fill it. Void consume ref hand side, and here we would say ref hand side RefHandSide, or just make it side, and take all of this, put it here, and even let's name it RefHandSide, and just replace ref right with RefHandSide, not like this, and say consume RefHandSide ref right, and here the same, let's say consume RefHandSide ref left. Maybe we can return it. If we are assigning, so it would be assigning the much already like this at the moment. Maybe we'll change it later. Let's try if it works. Yep, it does. Cool. Now the thing that I would like to do is also we have this consume entity name. It does nothing else. So let's see where we use it. Consume. Let's just delete it so we don't get used by it, and we say consume entity name. Do we have it somewhere? Yeah, we do. 1, 2, 3, 4. Let's then do substitute consume entity name with just consume name globally, and we have to add this. Yeah, let's check. Yeah, cool. Maybe one thing also to do is to pull out the way we parse the ref type, ref kind. Let's go where we have it, somewhere here. So we have this ref and we have this ref kind. So let's try to get it, maybe even not it, but from the ref, because it has a better error. Let's get it and say ref kind is consume ref kind. And here we would have ref kind, consume ref kind. The consume at the end. Maybe we would somehow do if not pick. We would somehow say an error here. Instead, we would do open type t is peak value type. We can switch, but we have the problem with this left right. So I say if it's left, then if and yeah, here we assume if it's right, consume and return many to many. Left, so it's one too many. It's right. Just return dash, it's right. We consumed it here. So let's say fatal expected origin sheep type got yof. Why not? And now we can have, yeah, here we consume ref kind and somewhere here. So let's say this and this and say ref kind is consume ref kind. Invalid relationship type. Now we have to probably remove it or no. Yeah, it comes from somewhere else. Table users. Let's see where we have it. Users here. It's posts. It's here or here. Oh yeah, because here I have to do so it was just incorrect error. What? Yeah, I have to change it. T is this and yep. Yep. Cool. So it seems to work. It seems to work. So we abstracted some things here and we also changed. So yeah, this is what we implemented today. So we just added schemas to everything. The nums to, did we add the nums? Yeah. Let me check, maybe we didn't. Oh, yeah, we added schema here, added the tables, added the columns in refs, both in inline and regular refs. And this is it for today. For next time, what we might consider is actually implementing those relationship settings. I completely forgot about them. And you see we have like they are the same for both keywords, and we might have to do some now for them and stuff, but we'll postpone it to the next one because it's already too much for one episode. So yeah, we would implement it, and then we'll look what else we can do. There are a lot of different things and a lot of refactoring we might do. So yeah, this is it for today. Like, subscribe, share. Have a good time, and see you in the next one.